Hello and welcome to the coding walkthrough video for Prototype 0.5.5. Now, you may be thinking, 0.5.5? What happened to 0.5? Well, there's a story behind that. And you can read the full thing in my weekly walkthrough. I think this is week 22 on my blog. Yeah, 22. But essentially, what happened to Prototype 0.5 is that, because the plan for this week was to code in the landing and takeoff mechanic. So the player can basically land on a planet and find the surface and walk around on it, and then take off and shoot off back into space. So that was the plan for this week, and I did a specific method of coding in Prototype 0.5, which was getting close to the planet and then loading a new scene which had the terrain in it, and then taking off again would then load to the original scene, this one, to get back to the universe or solar system. That code didn't work. It kind of broke for a lot of different reasons. It was overly complex, and the game had trouble with taking variables from different scenes and applying them in other scenes, and it all got very, very complicated and very, very broken, and I had to abandon it because it was just becoming too much like hard work, and it was just too... It wasn't worth it because it was taking an inordinate amount of time, and it didn't look like it was even going to work anyway. So Prototype 0.5 was abandoned, and Prototype 0.5.5 was born, which is basically doing the same mechanic, the landing and takeoff mechanic, but in a different way. So this one just... well, I'll show you in a minute. This one basically teleports you... once you get near the planet, it teleports you to a different location where the terrain is at, rather than loading a different scene, which is decidedly easier, as I found out once I was coding it. I wish I'd just done this one in the first place instead of wasting 3 days doing this load scene one, which didn't even work anyway. But that's beside the point. So, yeah, let me demonstrate the mechanic first, and then, as usual, we'll go through the code. And, yeah, right, so let's have a look. So we've got the astronaut and the ship just over here, so we'll head over to that. Get that way. Get in there. Slow. Oh yeah, so we've also slowed the ship down this week, as you might notice. Things are a lot slower. Rotation slower, and things like that. We did a user testing session on Monday, and one of the biggest, I'm not going to say complaints, but criticisms we got was that the rotation was too sensitive. So we've changed that, and it was pretty simple to do actually. All we did was up the ship's mass from 1 to 2 there. And I'm just going to check that we're actually capturing the cursor, because we weren't last time. We are. Fantastic. So yeah, you can see my cursor just hovering around the 2 number there. So we just up the mass of the ship so that it's heavier. So the same amount of force takes... well, a moving takes twice the amount of force it used to now, basically. So let's head over to the main event of this week, which we'll just mosey on down over here. Oh yeah, another thing I should point out, the planets have a different orbit system now. They are, sadly, on rails rather than being actually affected by gravity. I don't know why I paused it there. This is because the orbits were just too much, again, too much like hard work. They were too difficult to do, and because our game's large, and we're so limited for time because we have to keep going through everything because we've got the narrative and the environment to do and all this refinement to do. We've only got like a couple of months to do it, so we really can't spend ages and ages on one particular thing. It sucks. We wish we could, but we can't. So, and orbits were becoming really, really difficult because they would keep like disappearing off and things like that. Basically, they wouldn't be normal, so we just had to get rid of the gravitational pull thing and just put them in a big old rotate around the sun, which isn't ideal, but as you can see, they're smooth and they work nicely. So as far as I'm concerned, you know, it works. It may not be realistic, but it works. But yeah, on to the main event. You may be wondering why this planet is decidedly larger than the rest of them. It's a little experiment I was doing. I upped the mass of the planet and the size of the planet just to see whether it would have much an effect on gameplay. The answer is a lot. It massively changes how everything works. And actually, I think, is for the better. So expect to see every other planet in this system increased in size. It makes it a hell of a lot scarier for a start, because now the planet's huge and imposing. But if we get closer here, it also makes it quite a lot more difficult to land. You've got to kind of think about it because you've got to slow down. Like if you notice up here, you probably can't read that, but it says we're at 80 meters per second. We need to be at less than 10 in order to successfully land on this planet. So obviously we don't want to be going at 132 as I'm currently going. Crikey. Because I've got time scale up to 14. Trying to get the planet to catch me at this point. Come on, you. Yeah, there we go. You can see the line moving now. I'm not even holding the keys. Yeah, we are now caught in the planet's gravitational pull. Just slowly... Oh, God. I'm trying to slow down. Slowly pulling us down towards the planet, and there we go. Now we're in the atmosphere. Smooth transition, I know. Got to slow down. But yeah, as you can see, we've been transported over as the atmosphere moving past. Transported over to this... what's it called? Terrain. Obviously, it won't look like this in the actual game, but this is the landing mechanic in its most basic form anyway. I've just realised we are going at 30 meters per second. We want to be going at 10. Got to slow way down. 20 meters per second. 15. 14. Oh, we appear to be increasing speed. We are going up, it would seem. Yeah, we need to add some visual prompts to this particular bit because we're actually going up now, but there was no visual indication of that. Oh my god, that's a hill. Oh, touchdown. Come back here. Yeah, the bits of the ship aren't actually affected by gravity yet. I need to sort that. There's one bit. Come here. There we go. So yeah, touchdown. We are now down on a planet. Of course, because the ship is that way, and you get out on the right-hand side. I can't actually get out and explore. See if we can't take off anyway. No. Ooh. Come on. Come on, bits. No. Alright, well, looks like we're doing this bit without them. Oh, we got we got the gun back. Let's go. Ooh. No. Oh, that's actually unfortunate because now we're going to spin. No, come back. I need that bit. I need that bit. I need that bit. Please. Yes. Okay, hopefully we can still salvage this. We've lost the radar dish. So we're looking a bit like the Millennium Falcon in The Force Awakens now. Come on. Oh, I need that line to go upwards. We're still heading towards the surface. It's quite intense, this. That was one thing I noticed landing, is it's quite intense, even visually. Even though visually it's not intense. It's like, just landing and almost crashing, things like that is quite scary. So, oh god, I just got out of the ship. Don't do that. But yeah. It is quite freaky. Obviously there'll be a lot more visual prompts in the full game. This is literally just the bare bones landing and taking off mechanic, but it does work, and it works quite well, I think. So this is the... Here we go, heading out into the atmosphere here. Outer layers, and we are out. And if I press M... Oh, not quite yet. Keep pressing M. Yep, we are out. See that? Smooth transition. Out of the planet. But yeah, that is the landing and taking off mechanic, ladies and gents. What I will do just for a bit of fun. Speed up time just a smidge. Oh, we're back in the atmosphere. And we're going at 120, so we'll never save the ship at this speed. But we will, rather spectacularly, crash into the surface. So you gotta be really careful. You gotta be less than 10, otherwise you are gonna go splat. Yeah, but that's the new mechanic we've got. I think it works really, really well. It took a surprisingly long time to code. but it is in the game now. Obviously, there's a lot of bits that need refining and fiddling with, and I think especially on the planet, there needs to be some visual prompts. But all in all, it is, well, it's more or less there, isn't it? But yeah, what I'll do now is just quickly run through the code. So this is the center of attention, this update. And to start, we disable the elk loader surface, as it's called. That's basically the surface scene view. That surface there, we disable this upon startup because it's quite a large game object and it does have a bit of an impact on performance. So we basically just turn it off like this. So there only appears, well, I'll go through that in a minute. But yeah, on start, it's essentially disabled. And then we've got a little on trigger enter here, which basically goes if the player collides with a game object tied with elk loader atmosphere, which if we go to elk loader itself, see this on trigger, this circle collider, like just above the atmosphere of the planet, that is tagged with elk loader atmosphere. See, there it is. So yeah, basically if you get within those confines of the atmosphere, then set the surface to true so that it appears. Set the transform position to for the player and the camera to this position, which is basically just above here, I think. That position there putting the player right above the surface. Set the timescale to 1, because we found that if you don't do that, then the player splats really quickly if they're on high enough timescale. You know, they don't have time to react. So we just reset the timescale to 1. Now this is a rather interesting one. It gets the current velocity of the player and applies it downwards, basically. So if you're going at 100 meters per second, it gets the 100 meters per second, but it applies it at a downward rate that way. So what that basically means is, because allow me to explain that. If the player's approaching this planet from that direction, going from here to here, say, then the velocity that he's got will be in that way. So if you were to just apply the velocity and not apply a downwards force, then what happens when the player teleports to here is it will just keep going in that direction. Whereas this way we're applying a downward force but times the velocity, so he keeps the same velocity but applies it downwards, so it goes towards the surface as you would if you were approaching a planet. So that's just a bit more adhering to the more realistic side of space travel there. And then lastly, we set the in elk loader atmosphere boolean to true. Now this code is it's quite easily applicable to all the planets. All we'd have to do is write tags for each of the worlds and all these vector 3s and things like that, and then add them all here. But it would all work in the same kind of manner. So this script works quite well with every planet, because obviously at the moment elk loader, the Mars planet, is the only one you can actually land on, but it will be relatively simple, and that will happen in the coming weeks to implement the rest of the planets to make them all landable. All the ones that we want the player to land on anyway. So, and then the next bit is if you collide with the game object tied with escape elk loader, which is over here. Basically any of this box. So this box is basically to stop the player wandering off the edge of the world. If he jumps off the edge of the world, he'll jump off the edge of the planet and head off into space, basically. But if the player collides with any of them, then set the player's transformed position to the X and Y of the elk loader planet, basically of wherever the planet elk loader is at a given time. And just for clarification, that is that world there. So wherever that planet is at the time, but give it an offset of 4,000 so that you appear above it, so that it looks like you've taken off, basically. And then the Z position, just for safekeeping there. And then disable the elk loader surface for performance, and then disable the in elk loader atmosphere boolean because you're not in the atmosphere anymore. Then we've got a little function here that basically checks to see if the gravity scale is greater than 0. Now this is a general one, this doesn't specifically apply to elk loader, this is for all planets. Basically if the gravity scale is greater than 0, which it only will be if you're within a planet's atmosphere, then the boolean for in planet is set to true, and it increases your flight speed to 400 because, well, in real life ships have planetary boosters to escape gravity that are decidedly more powerful than ones they use in space. So this is basically enabling, even though there's no visual prompt for this yet, there will be, It's enabling planetary boosters so you can escape the gravity if you want to. Otherwise, set the in-planet boolean to false. This boolean is used in subsequent scripts, as I'll talk about in a second. And then if the in Alkalode atmosphere boolean is true, which it is if you enter Alkalode's atmosphere basically, then set the gravity scale to 0.25f, and set the current distance, which is this bit down here, which I'll talk about in a second, to the Alkalode distance. Otherwise, set the gravity scale to 0, because if you're not in the planet's atmosphere, then you'll be in space. And this can also be applied to, well, in a similar manner to these ones up here. You've got to write a new boolean, but they can be applied relatively easily to the rest of the planets, or landable planets in the system, when I come to implement them anyway. So then we've got another function down here called Alkalode landing, and this is a vector 3 here that basically calculates the difference between the Alkalode surface's transformed up position and the player's transformed up position. And then this vector 3 here is just calculating Alkalode's transformed up position. So what that basically means is if you're within the atmosphere of Alkalode, then the current distance vector 3 is equal to the Alkalode distance vector 3, which is basically, it takes the surface position of Alkalode and takes away the player's position. It sounds very complex, I know, I'll explain in a minute, I promise. And then these functions are just called here. So now we talk about the distance bit. So that distance, the current distance vector 3 that we set up here is called here. And if the in-planet boolean is true, which it will be only if you're obviously within a planet, then it is displayed on the UI. And what that basically means, I won't actually be able to show you here because I'll have to land back on the planet again, that takes forever. But as you probably saw when we were landing on the planet, another thing came onto the UI here, which was the distance between the player and the ground, which it gives you a visual reference to show you how far away you are from crashing or landing, basically. Currently it's just for debugging. I don't know whether it'll actually be in the game, the full game, but it's useful, because otherwise I don't know how far away I am from the ground because of the game zoom level. But yeah, so there's that. But this GUI line of code takes the current distance variable, which can be anything. So if you're in Alkalode's atmosphere, it'll be the Alkalode distance, but if you're in, say, I don't know, Diadem's atmosphere, then it can be set to Diadem's. So it'll basically be set to whatever planet surface you're currently about to land on. And then finally, the last bit is just, this hasn't actually been changed, but I'm going to show you it again just as a reminder. But if you collide with something tagged with space and your velocity is greater than 10, then you'll get destroyed. And that has been applied to the surface of Alkalode, because obviously if you crash into it higher than 10, you just blow up, because crashing into things at high speed isn't generally advised. And then the last thing I've got to show you is the taking away of the gravity on the planets. So as you can see here, and with most of these, all the orbit system scripts have been disabled and replaced by the moon script, which is something I added in the last prototype, but I'll just show you now anyway, just to give you a bit of an idea of how the orbiting works when it wants to load. Basically, it replaces the gravitational, here we go, it replaces the gravitational orbiting with just a simple transform dot position and a transform dot rotate around. And all that does, if we just stop it from maximizing, so I show you in scene view, all that does is it basically gives let's up this actually by a lot. It makes the planets just rotate around the sun, rather than actually rather than actually orbiting the sun via actual real gravity. It's just to rotate around now. It's a lot simpler now though, as a result. So while it is a bit of a shame that it's not realistic gravity, it actually behaves and they don't go wandering off and you don't hit them. Because one interesting glitch we had last week was that when Josh accidentally hit into one of the planets a bit too hard and actually knocked it out of its orbit and it went flying off. which obviously shouldn't be possible, but it is in this game. And that was actually one of the major things that made us decide we needed to get rid of it, because it just wasn't working the way we wanted to. But yeah, so that was prototype 0.5.5. Next week is a quality of life update, so a lot of new things are going to be like refined and fiddled with. But don't expect a massive update next week, as we're all working on our reflective journal option module, and that's probably going to take up most of the week. So development's probably going to slow down for a bit, which is unfortunate, but it can't be helped. But yeah, I hope you enjoyed that, and I'll see you in the next one.